Hello, this is Timothy Southwick from Team Technobytes for Microprocessors 2, and this is my code for Lab 3. Currently we don't have the kernel, well, we compiled the kernel, but we haven't applied it to the board yet, and the driver does not yet exist, so this is mainly built upon my code from Lab 2. So it first makes sure that the I2C enable pin, which is pin 29, is set to low so that the I2C bus is enabled. And then it will prompt whether or not the user wants to set the clock at the beginning of the program. This is so that the user can set the timestamp at the beginning of the program or test if it successfully set this clock and kept time after a restart. Now, I suppose I could start with the setTime function. I've got a structure that contains the time data numerically and as a C string, a character array. So we create a buffer for the I2C data. You start by setting the values for our time structure to invalid values that are easily identifiable in the event of an error, such as the year 100 out of the value 0 to 99, and prompting for user input. It should then store the values in an input buffer and prompt for the next value, but not write the values until it has all valid values. So I've got a bunch of error checking to make sure that there isn't any invalid values entered by the user. It keeps prompting until there's valid values entered, or until you hit Control-C and cancel the program, one or the other. And once it has its full buffer, it will then attempt to open the I2C device on I2C-0, and it will check for errors throughout the code, printing errors if needed. IO control to make sure that it is set as a slave device and specify which address it is we are talking to. That would be the I2C address rather than the register address. It should then proceed to write the current buffer of all of the I2C time data to the clock, and then go back to the beginning of the register so that it can read it all back and make sure that it is correct. Oops, I actually forgot the code to check if its values are correct, but it will go back and check what the values are, but not actually do anything with it at the present time. Apparently I define the struct after I set time. Back to main. There are two functions in my code for specifying the time. One is for printing out to the display. It will print it out in human-readable text format. And the other one is for the log file that is easier to read by machines, such as a spreadsheet editor. It will then proceed to open the spreadsheet file, the CSV file, comma-separated value file. That will be the data log output, which will be written to throughout the code. The majority of the following code is copied from Lab 2 to talk with the PIC controller and acquire data from the ADC. It will loop checking for the device. If it succeeds in finding the device, it will send a reset signal, and then as long as the valid responses are coming in, it will attempt to acquire values and display them on the terminal, as well as writing them to the log file. And as soon as it receives an invalid packet, it will say so, specify which value it received instead of the expected one, and repeat until you hit Control-C to end the program. And throughout the program, it will also perform a getTime function either in the log format or the human format. Either one is set through its own function, which simply prints out the values from the time structure that is received from the function getTime. GetTime will also specify invalid time values, such as the second value 60, minute value 60. It will specify that it is QM rather than AM or PM, so it will be very clear that the values it is reading are incorrect and that it is not properly talking to the I2C clock, or otherwise the I2C clock has malfunctioned. Again, open the I2C bus, select which address we are talking to, specify which register it is we are going to write to, and attempt to read values from it, storing them within the time structure. That time structure is returned. It is interpreted by the getTime human and getTime log functions and pasted directly into fprintf. And actually, there's an interesting tidbit about how the getTime log and human functions work. They require a character array for the string that is going to output the format in. However, this is not convenient for printing out through printf, so I return the same pointer that is provided to it, so that it not only stores the value to the string specified, it also returns that string. And so far it looks like all of that code is working in theory. However, it would appear that our clock is not communicating properly with our device. I cannot seem to see it through the command I2C detect -R specifying that we wish to read from the device, 0 specifying which bus we are talking to. Currently, my computer does not have an I2C-dev module loaded, so it will not display anything. However, on the Galileo, this will properly display that there are devices built into the Galileo, but not the one we are specifying is at address 0x68.
Maybe you can conclude if you have something.
I believe that is all for today, and I guess that's it.